Vertex form is the very first form of a quadratic equation that we are going to learn about, and is of course the focus of this particular section. What vertex form is we will define the output variable y to be equal to, and of course there has to be x to the power of 2 is the highest exponent, since that's what makes something quadratic. Now what we're going to see is we're going to see some various transformations with parabolas here, where we're going to have some horizontal and vertical translations, compressions, and stretching, and all that sort of stuff. It's going to be very similar to what we saw with the absolute value functions. So inside that parentheses with x, we may actually be squaring a quantity where we may be subtracting some number h from x, or possibly subtracting a negative number, which means we're adding some number ultimately inside the parentheses. And then also we may do some adjusting of the equation by adding some constant k, and if k was negative, then we added a negative, so really subtracting maybe. And then also multiplying by some value a, and a might be positive or might be negative, which has some effects on the graph there as well. So some characteristics that we're going to see about graphs that are expressed in vertex form might include the following. So the graph may open up, meaning that the parabola is just kind of an upwards facing sort of U shape, whereas sometimes we will see the parabola will open down. And to be able to distinguish between those particular cases, it does turn out that the parabola will always open up when the value of a in your equation is always above 0. In other words, if it's positive. So if a was 1/5, or if a was 42.3, like your parabola is always going to open up. Whenever your a value is negative, then your parabola is just going to flip upside down and be an upside down sort of facing you. Of course, if a was equal to 0, you wouldn't have a quadratic equation because you wouldn't have an x squared term. So it's at least got to be positive or negative for your a value. The graph may be vertically stretched, and when it's vertically stretched, that means it's a little bit skinnier than normal because you're kind of stretching it like a rubber band in a vertical direction. And the same thing could be true like when it's upside down too. Versus the graph may be vertically compressed, which means it's a little bit flatter like a pancake, which ultimately makes the U become a little bit wider. And the way you can tell the difference between those particular things is whenever the absolute value of your A is going to be greater than 1, that's when it becomes vertically stretched. So that's when you have numbers like 2, or when you have a negative number that's less than -1, so like -5/3. A graph will be vertically compressed whenever your a value has an absolute value that is less than 1. And really that's equivalent to, that's the same thing as saying that -1 is less than a is less than 1. So anytime your a value is between -1 and 1, just I guess as long as the a is not equal to 0. To be able to identify a y-intercept, it's not unique to just quadratic functions, because whenever you have a y-intercept of a graph, we always know that the x-coordinate is going to be a 0, and then you're going to have whatever number it is that is crossing through the y-intercept. So in terms of actually being able to find a y-intercept, if you substitute in a 0 for x, and then you solve for what the corresponding y value would be, that's going to be your particular y-intercept. And then to be able to identify the axis of symmetry as well as the vertex of the parabola. So keep in mind that whenever we have a parabola, that this point kind of at the tip of the U shape right there, we denote as the vertex always of the parabola, and then the axis of symmetry is going to be that line that cuts right directly through the parabola. It's actually very easy and convenient to find a vertex when the equation is in this form right here, when it's in vertex form. And there's a reason why we call this vertex form, because the vertex form is basically kind of staring in front of your face when you look at the equation if it's expressed in vertex form. What I mean by that is this h right here actually does correspond to the exact number of units of horizontal translation of your graph of the parent function of y equals x squared. So for example, if h was actually the number 4, then you are actually going to move right 4 units. Now keep in mind then, if h was a positive number and you plugged in the 4, you're going to see x minus 4. So whenever you see a minus inside the parentheses, that's going to indicate that you're moving to the right. But if like h was like a negative number, so if h was negative 2, then you'd actually be moving to the left 2 units. So if you did plug in a negative number, then you'd have x minus negative 2. So because of that subtracting a negative, you're actually going to see then a plus inside the parentheses whenever you have a left shift of your graph. For the k value, that actually does correspond to the number of units of vertical shift or vertical translation of the graph. For that number that's outside the parentheses that you add or subtract, if k was, let's say, a positive number like 5, then that will be an upwards shift of the graph. Whenever k is some negative number, so like -1, that will be a downward shift of the graph. Note that there you do have a plus sign, so then when k is positive, you will see plus, and then when k is negative, you will see minus on the outside of the parentheses there in particular. So because of all that convenientness, it does actually turn out that the vertex of your graph will actually have coordinates h, k. In other words, this number right here and this number right here tell you exactly where that vertex is going to be because they correspond to the exact number of horizontal units of shift as well as vertical units of shift. And then it just also turns out that then for the axis of symmetry, it's actually going to correspond to the same x value as your vertex, which means this same h number is going to be what it crosses through. Now, because an axis of symmetry is really a line, a vertical line, its equation is actually just x equals whatever number h is.